Right, you're joining into 2020 Inorganic Structured Essay question number 2 actually. So this question carries 100 marks. So when you divide it by 20, you have 5 marks in the A-level paper. So this question has part A and part B divided into two sections. So both are, from the P block, they're asking these two questions. So S block, not much here in this question. So first of all, compound A, B, C, D are chlorides of P block elements. These elements have atomic numbers less than 20. A description of the products P1 to P9 formed when A is reacted with limited amount of water. So here you have to note that these products are formed when you react A with limited water, right? These products are formed when you react A with limited water, whatever A it is. You're going to react that with limited amount of water. So you get these products. And meanwhile, B, C, D are reacted with excess water. So these products are obtained when you react with excess water. So these are obtained when you react with excess water. So that's the difference. That's the difference, right? Now A is going to react to form a compound with a covalent network structure and a strong monobasic acid. So in the group, actually in our WhatsApp group, I sent you all the compounds that will form a covalent network structure, right? So silicon as an atom can form covalent network structures. SiO2 can form, SiH4 can form, aluminium hydride, AlH3 can form, and also carbon, diamond and graphite can form, right? Diamond and graphite can form. So these are the compounds which can form network covalent bonds. So here, compound with the covalent network structure and a strong monobasic acid. So where do you see this in our inorganic note? People, under hydrolysis of compounds, we have all the hydrolysis of chlorides given in the syllabus. So there, from that you can see this hydrolysis is coming from SiCl4 hydrolysis. SiCl4 limited amount of water, again like limited hydrolysis, limited amount of water, it's going to form SiO2 and HCl. So this is SiO2 and this is HCl that they're talking about. So A is going to be SiCl4, right? A is going to be SiCl4. And then B, a gas that turns red litmus blue and a compound which with bleaching properties. So now here they are talking about NCl3. Now it will evolve ammonia. Where do you learn this now? This one you're going to learn in group number 15 under ammonia, right? Production methods of ammonia. From that, addition of NCl3 into water will give you ammonia. Also, we discussed this under hydrolysis of chlorides of group 15. So there you go, gas that turns red litmus blue, that is ammonia. Compound with bleaching properties. What's the other compound that is formed? HOCl, right? NCl3 added into water, you will form ammonia and HOCl. So this is, I'll write it in another color. So this is ammonia and this is HOCl, right? So this is going to be NCl3. C will form a tribasic acid and a strong monobasic acid. Now they have told in the question here the atomic number is less than 20. So the other one which you can have is phosphorus. We can write the PCl3. We can write the PCl3. And then D, a gas that turns acidic KMnO4 solution colors a colloidal solid. A colloidal solid. Where do you see a colloidal solid? SCl2 addition into water, right? SCl2 when added into water, you will form sulfur, which is this colloidal solid, and a strong monobasic acid. That strong monobasic acid is HCl. And here gas that turns acidic KMnO4 solution colors. We are talking about this because SO2 is formed. SO2 is formed, but in the resource book, they have given the reaction like this. SCl2 plus H2O will form sulfur, H2SO3, and HCl. Right? This is the reaction they have given in the resource book. This is because SO2, which is formed by this reaction. Now, normally SO2 is formed. SO2, which is formed from this reaction, is going to react with water to form H2SO3. Now, that will happen. So that is why in the resource book, they have given it like that. But here you have to have the brain to understand that they're talking about SO2, right? That they're talking about SO2. So SO2 is the gas that turns acidic KMnO4 solution color. So keep this at the back of your mind. They have a chance of asking this again because they haven't asked this point since 2020. So keep this in your mind. And D කියන්නේ, yeah, this one is Cl2. There you go. Then give the balanced chemical equations for the reaction of ABCD with water to give products P1. I mean, like, you can write that, right? You can write that. That's easy. I won't discuss this. I have discussed how to identify the compounds, but I will not discuss how to write balanced chemical equations. That's easy. So once you identify the products, writing equation is easy. It's about writing the stoichiometry properly. Write balanced chemical equations for the following reactions. Now P1. P1 is SiO2, right? SiO2 plus NaOH, right? SiO2 plus NaOH. This will form Na2 SiO3, right? It will form Na2 SiO3. Now you can balance this reaction out. P3 with magnesium. So what is P3? Ammonia, right? Okay, ammonia reacting with magnesium. This will form magnesium nitride, Mg3N2, and hydrogen, right? Mg3N2 and hydrogen. So magnesium is going to react similar to lithium. Now lithium and magnesium, I'll tell you an extra point. Lithium and magnesium reacts to form the nitride, right? Nitride. Meanwhile, others, for example, sodium and all, they are going to form the amide. I'll write that reaction also. Ammonia plus sodium will form NaNH2 plus H2. This is the product formed when you react it with what do you call sodium, potassium like metals. Right. So lithium and magnesium will only form the nitride. Others will form the amide. P7 with acidic K2Cr2O7. P7 කියන්නේ මොකද්ද? P7 is SO2, right? So now that's a reaction you have to balance using redox. Cr2O7 2 minus will form Cr3 plus. So this will undergo reduction, and SO2 will undergo oxidation to form SO4 2 minus. So it's about balancing this reaction. You can balance it separately in a rough worksheet, and then you can write it here in the question paper. So here, don't worry, they have not actually expected you to write the total compound as the reactant. So Cr2O7 2 minus, if you write, it's going to be fine, right? It's going to be fine. So ionic reaction is fine for this third Roman number. They have given full marks, so you get 6 marks if you balance this and write. Then we are moving into the part B. Right, let's look into this now. A student is provided with bottles labeled PQRSTU and containing aqueous solutions of aluminium sulfate, H2SO4, Na2S2O3, and barium chloride. Lead, now AC means acetate, lead acetate. Acetate stands for CH3COO minus. This iron only acetate can. So this is there in the laboratory. You can see this inside a bottle. So lead acetate is there. So and KOH and not in order. They are not in order. Okay. Some useful observations for the identification on mixing two solutions at a time are given below. They have given AC is acetate ion. Okay. Now T plus R gives a colorless, clear colorless solution, and P plus R gives a white precipitate. T plus L gives a gelatinous white precipitate. Now there are 3 gelatinous white precipitates in the syllabus you need to know. That's aluminium hydroxide, magnesium hydroxide, and the other one is zinc hydroxide. So these are the only gelatinous white precipitates in the syllabus. So it should be one of them. There is no zinc here. There is no magnesium here. So the only one is aluminium reacting with KOH to form aluminium hydroxide. So one of these should be, so I'll write here Al2, Al2SO43, and what are the possibilities? KOH, right? Now it can be T and S, but T can be aluminium sulfate, and then S also can be aluminium sulfate. We don't know about that. So there are 2 possibilities here. So I'm going to write it like that. Then what is the next thing we can see? So white precipitate turns black on standing. We can crack that, right? Turns black on standing. What are the 2 white color precipitates that turns black on standing? That's the lead acetate and silver acetate. Right, lead acetate and silver acetate. So lead acetate PbS2O3 will form PbS and SO3. Now SO3, if there's water, it's going to form H2SO. So you have to keep that in your mind. My idea is now PbS2O3 will undergo decomposition. Actually, you should heat this. You should heat this in order to make this reaction happen. But there's another one, Ag2S2O3. Ag2S2O3 turns black on standing. You just have to leave it like that. It's a white color precipitate that turns black on standing. This one also a white color precipitate that turns black on heating. Right? So Ag2S2O3 turns black on standing. It will form Ag2S, which is black color, and forms SO3. SO3 will react with water to form H2SO4. So if this reaction is happening in aqueous medium, you have to write this one and this one as the product. And if this reaction is happening in what you call normal conditions, only Pb2S2O3 there, then you have to write this one and this one. So keep that in your mind. So turns black on standing. Turns black on standing කියන්නේ P plus Q, it should be definitely lead acetate and sodium thiosulfate. Right? Lead acetate PbS2O3 and Na2S2, sorry, my bad, lead acetate ne, PbAc2, right? Something like this. Right. Then we are moving on. P plus Cu, white precipitate that dissolves on heating. Okay, now that one comes with white precipitate that dissolves on heating. Okay, now this one comes with PbCl2. It doesn't turn black color, but it will dissolve. It will form a colorless solution once you boil it or heat it or something like that. So you know what it is. It is the lead nitrate test. It's a lead nitrate test in halogen identification where you add Pb2 plus ions, lead ions, which will form PbCl2, which is a white color precipitate. Then you boil this to form colorless. You boil this to form colorless solution, and then it's like water then, right? When you make a colorless solution, it's like water. And then you cool it again. When you cool it again, it will form a white needle precipitate. Actually, white needle you can see at the bottom of the test tube. So this is what they're talking about. So I'm going to write it. White precipitate dissolves on heating. So this is going to be definitely forming lead chloride. It should form definitely lead chloride. So it will be lead acetate and barium chloride. Lead acetate and barium chloride. PbAc2 and barium chloride. So now you can see lead acetate is repeated in two of these, and it should be definitely P, right? So we have identified P. So P is going to be lead acetate, PbAc2. And then Q is going to be sodium thiosulfate. That one also done. Na2S2O3. And U is going to be barium chloride. Right? U is going to be barium chloride. Now we know what is U. So we know what is this. We know what is P. So we know what is this. We know Q. So we have cracked this, right? This one and this one done. We don't know T. We can find R. We can find R available by now P plus R is a white color precipitate. U plus R is also a white color precipitate. So U is barium chloride. Barium chloride like a white color precipitate, it will form by sulfate. It will form with sulfate. Right? It will form with sulfate. And also P is lead acetate. P is lead acetate. Lead acetate will join with now Q is sodium thiosulfate ne. Either P and R is going to be then H2SO4, right? Yes, R is going to be H2SO. If we put R as H2SO4, what will happen? Let's see. So R, let's trial and error. Okay, this is trial and error. I'm going to put H2SO4 in the place of R. So H2SO4 and lead acetate will form lead sulfate, which is a white color precipitate. That's fine. So H2SO4 also reacts with U. U can call the barium chloride form barium sulfate, which is also a white color precipitate. So that's also fine. So R is there. R is there. And R is there also. So R plus T gives a clear colorless solution. I'm guessing T to be KOH. I'm guessing T to be KOH because it doesn't give any precipitate or anything. Guessing, okay? Just see, let's see. And S gives a gelatinous white precipitate. So if it gives a gelatinous white precipitate, definitely T is KOH and S is aluminium sulfate. Al2SO43. There you go. I think now everything is correct, right? Here you go. AlSO43 and KOH. So T is KOH and S is going to be aluminium sulfate and remaining one is H2SO4. There you go. That's how you crack this inorganic question. Then second Roman number give the balanced chemical equations for 1 to 6. ඒක කරන්න පුළුවන්නේ. Right, balanced chemical equations. Can check the marking scheme also for that. Once you have identified, then the rest is nothing. Fifth one, formation of white precipitate and turns black on standing, and the sixth one is indicate precipitate as by a downward arrow. I mean, like this one you can do alone. So that is the 2020 inorganic structured essay question. Not much hard, little bit hard. Like without knowing inorganic well, you can't do this part B section. So yeah, let's meet on another structured essay question.